Hello everyone. So in today's lecture, let us see the 7 properties of light. So the first 7 properties that are reflection, refraction, dispersion, scattering, interference, diffraction, polarization. So these are the 7 properties of light. Now the branch of physics which deals with these properties of light, we call it as optics. Now let us see what is light. Light is a form of energy which causes sensation of vision to the eyes. Light is a form of energy which causes sensation of vision to the eyes. And now let us start discussing about these light properties. The first one is reflection. Now the best example, if we throw any ball towards a wall, what happened? It bounces back. So now here it is bouncing back in same medium from which medium it has gone towards the wall. In the same medium it is bouncing back. So that bouncing back of the light rays, we call it as reflection. Now here in diagram, this is the boundary separating two medias, two different mediums. Now this is the normal drawn to the boundary. Now this is the incident ray. Now when it incident on this boundary or interface, it bounces back or reflects back in the same medium. So this we call it as reflection. Now this ray which has incident on the boundary, we call it as incident ray, and this ray we call it as refracted ray. Now next, the angle between normal and incident ray, we call it as angle of incidence. Angle between normal and reflecting ray, we call it as angle of reflection. Now incident ray means a ray of light traveling towards another optical medium, that we call it as incident ray. And do you know what is normal? Normal is nothing but a straight line drawn perpendicular to the boundary or surface. We call it as normal. Now next, here let us go for some other points such as plane of reflection. So what is plane of reflection? The plane which contains incident ray, reflected ray and normal, we call it as plane of reflection. So this becomes plane of reflection. Here incident ray, reflecting ray and normal, these 3 are present. So this we call it as plane of reflection. Now similarly, reflection is of 3 types, right? One is regular reflection. This is also called as specular reflection. Other is diffused reflection, and the third one is multiple reflection. So regular reflection means the reflection which takes place from smooth mirrors. Here when the light is incident on clear and sharp mirrors, it refers to clear and sharp reflection. This happens in mirrors itself only. Mirror, it reflects almost all the light incident on it uniformly. Now diffused reflection means just in your homes you may have observed some mirrors which are having rough surfaces. That rough surfaces may be due to the dust particles present on it or due to the scratches present on that mirror. So when this light is incident on such rough surfaces, this reflected after reflection, they totally reflect completely in some different directions. You see, now this light is reflected in this direction, this incident ray is reflected in this direction, this is reflected in this direction. Means after reflection completely they will go in some different directions. So here reflection is not uniform. Okay, we will find non-uniform reflection. So such kind of reflection we called it as diffused reflection. And there is a use of this diffused reflection. The use of this diffused reflection is that we will become enabled to see non-shiny objects. So shiny objects means as usual we can see easily due to its shining nature. But non-shiny objects, now if you want to identify or see non-shiny objects, this diffused reflection will help us a lot. Next, multiple reflection. Now multiple reflection means if we place two or more than mirrors, so light reflects from each mirror, so multiple times it reflects. So and at the same time in big shopping malls you may see, if we see image, we will find the image in every individual reflection. In big shopping malls we will see number of mirrors will be arranged. In each mirror we will observe our image. Okay, this is multiple reflection. Now next, then how to know how many images are formed? If a number of images are formed, then how many images are formed? The total images depends upon the angle between the two mirrors itself only. So number of images is equal to 360 divided by angle between mirrors. Number of images is equal to 360 divided by angle between mirrors. If angle between mirrors decreases, number of mirrors increases inversely proportional. If angle between mirrors decreases, number of images increases. If mirrors are parallel to each other without making any angle, if they are parallel to each other, then number of images becomes infinite. Okay, if they make certain angle, they are inversely proportional. If angle increases, images decreases. If angle decreases, images increases. But if mirrors are placed parallel, then images become infinity. So now this multiple reflection we will see in barber shops. In front of the person a mirror will be there, and back side of the person also barber will keep a mirror. So such multiple reflections in barber shops, best example we can see. Now the question is, we say that angle of incidence is equal to angle of reflection. Why? Why R becomes R is I equal to R? Why means, let us see Fermat's principle. Fermat principle says that light chooses the path which takes the least time to travel. Light, it chooses the path which takes least time to travel. So when light gets reflected from the surface, it selects the path that takes the least time to travel. Because of this reason only, angle of incidence will be equal to angle of reflection. And at the same time, in plane mirror, the size of image is equal to size of object. Distance of our image in plane mirror is equal to distance between mirror and yourself. Okay, these are the points to be known. Do you know about laws of reflection? One is, the first law says that angle of incidence is equal to angle of reflection. Why it is happening? Because light every time tries to choose the shortest or least path. Okay, that particular path which takes least time to travel. So only I will be equal to R. This is the first law. What is the second law? The incident ray, reflected ray and normal lies in same plane. One is I equal to R and other is incident ray, reflected ray and normal lies in same plane. Right? Now next, reflection in some of the applications in daily life. Reflection we see in mirror, spherical mirror, water pool, polished surface, glowing of stars only due to the reflection of lights, lighting of moon at night due to reflection of light. Now next, let us move for the second light property, refraction. Now here we are talking that we said that the light when incident on the boundary separating the two medias, the light bounces back into the same media. Now let us think that light is traveling from rarer to the denser medium. Then how the light changes, whether its direction change or not, let us see. So now here, this is, let us think as air, rarer medium. This is glass, denser medium. Do you know what is rarer medium? Rarer medium means that particular medium in which the molecules are at a distance from each other. So the density of molecules will be very less. And denser medium means that particular medium where the density of molecules is more. So now when a ray from rarer to denser medium it is traveling, when it enters into the denser medium, as the density of molecules here is more, it changes its direction and travel. It changes its direction and travel. Actually, if a denser medium is not present, the light has to move in such a way, in a straight path, because the light moves in straight path. So it has to move in such a path. But in denser medium, instead of moving along this path, it changes its direction and move. So that change of direction of light from one medium to another medium, by change in speed, we call it as refraction. Why this direction is changing? Only due to the change in the speed of the light. Right? The angle between the normal drawn and refracted ray, we call it as angle of refraction. Right? Now next let us see the laws of refraction. The first law is the incident ray, refracted ray and normal to the interface of two media at a point of incidence lie in same plane. The second law is Snell's law. What is Snell's law? The ratio of sine angle of incident ray to sine angle of refracted ray is equal to constant. This is the second law. Now next, already we defined angle of refraction, nothing but angle between the normal drawn and the refracted ray. Now here, then we are saying that light is changing its direction. Light may travel from rarer to denser medium and denser to rarer medium also. Then how its direction is changing? When if light ray travels from denser to the rarer medium, then it bends away from the normal. This is the normal. It bends away from the normal. And if light travels from rarer to the denser medium, it bends towards the normal. Okay, when light travels from rarer to the denser medium, it bends towards the denser medium. Like, now do you know the velocity of light in vacuum? 3 into 10 to the power of 8 meters per second. Okay, now let us see where we will find the diffraction in real life. In a mirage formation, let us discuss this formation of mirages later. Now swimming pool always looks shallower due to this light coming from bottom of the pool bends at the surface due to refraction. Okay, now formation of rainbow. When white light passes through the prism, it splits into VIBGR. Now let us discuss all this application in the next, after completion of these some fundamentals. Now application of refraction of light. Okay, now lenses. Lens uses refraction to form image of an object for various purposes. Now refraction is used in p-holes of house. P-holes means for doors we will have holes. So outer side person cannot see inside, but the person who is inside, he can see who is outside the door. Now cameras, movie projectors and telescopes. Okay, now next, refraction principle is also used in spectacles worn by the people with a defect of vision. Okay, in a last video I discussed about myopia, hypermetropia. Okay, once check that video. Now next, refractive index. So refractive index gives the ratio of speeds of light, that is speed of light in vacuum to speed of light in medium. It is also called it as absolute refractive index. Refractive index, as it is the ratio of speeds only, it will not have any units. Units cancels, because this is speed, this is speed, meter by second, meter by second. So it will not have any dimensions or units. It is a dimensionless quantity. Now then, what is the purpose of refractive index? It gives us idea how fast or how slow the light travels in vacuum. Right? Now here, if we go for some examples, kerosene have highest refractive index. It is denser than water, although its mass density is less than water. Refractive index depends upon nature of material and wavelength of light. And now let us see some of the examples, such as, now the velocity of light in turpentine oil and glycerine will be same, because refractive index is 1.47 for both. The velocity of light in palm oil and kerosene will be same, because refractive index for both is 1.44. The velocity of light in petrol and Canada balsam is same, because refractive index for both is 1.55. The velocity of coconut oil and kerosene will be same. Velocity of light in these will be same, because their refractive indices are 1.44. Similarly, the velocity of light in diesel and kerosene, velocity of light in water and vinegar will be same, because refractive index for water and vinegar is 1.33. Okay, now let us discuss about critical angle. Okay, now for discussing the critical angle, now see here. Now here, this is the boundary separating two medias, medium 1, medium 2. Let it be denser medium, let it be rarer medium. Now here, one light ray has incident coming from denser towards the rarer medium. It refracts. Now just go on increasing angle of incidence. Okay, as you go on increasing angle of incidence, at one particular angle of incidence, this refracted ray grazes this boundary, means touches the boundary or passes along this boundary. Means here the angle of refraction has become 90 degrees at one particular angle of incidence. The refracted ray grazes the boundary separating the two medias. Means at that particular angle of incidence, angle of refraction has become 90 degrees. So that particular angle, at which angle of refraction becomes 90 degrees, we call it as critical angle. We call it as critical angle. Now next, here let us go for total internal reflection. Now here, as now I said, first at one particular angle of incidence, the light is refracted with an angle theta 2. Now as you go on increasing angle of incidence, at one particular angle, that is at a critical angle, the refracted ray becomes 90 degrees. The refracted ray becomes 90 degrees. That is at critical angle, the refracted ray grazes the boundary. Now increase this critical angle greater than angle of incidence. Increase when angle of incidence is greater than critical angle. Now the light ray, without entering into the rarer medium, totally reflects back into the denser medium. So when angle of incidence is greater than critical angle, the light ray, without entering into the rarer medium, totally reflects back into the denser medium. So that phenomena where the light completely reflects back into the same medium while traveling from denser to the rarer medium at a critical angle, we call it as total internal reflection. So the main conditions for this is, one is the light rays must move from denser to the rarer medium, and the second condition is angle of incidence must be greater than critical angle. Okay, the angle of incidence must be greater than critical angle. That we call it as a total internal reflection. Some formulas: N1 by N2, refractive indices of both medias, equal to sin R by sin I, and critical angle formula sin theta C equal to N2 by N1. Okay, and the examples are diamond shines. Do you know why diamond shines? Only due to the total internal reflection. When light passes, when it tries to pass from diamond is a denser medium, when tries to come out into the rarer medium, the angle of incidence becomes greater than critical angle, so it totally reflects back into the same medium, and that reflection only we are seeing as shining. So only diamond shines only on the principle of total internal reflection. Now my rages, in next, after completing next topic, I will explain. Now presently optical fiber. So here also, by using fibers, what we will do? We will, major fibers are used in communication purposes. So what happens? First light ray enters. Here I becomes greater than IC. It reflects back. Again I becomes greater than IC. Again reflects back. Here also again I becomes greater than IC. In such a way, total internal reflection takes place. If we send more than one ray, the same thing happens. Okay, the same thing, total internal reflection takes place, and all rays comes out from the fiber simultaneously. In such a way, a distortionless signal is formed. Okay, now dispersion. Dispersion means splitting of white light into 7 different colors. We call it as dispersion. Then how light is refracted through glass prism. Actually, light is refracted towards base of the triangle. So different colors of spectrum of light have different wavelengths. Violet has one wavelength, red has one wavelength. So different colors have different wavelengths. So violet bends more because of shortest wavelength. Red bends least due to longest wavelength. Okay. So now if we see this with jar, see, violet bends more. If this is the incident ray direction, violet bends more because of its shortest wavelength. Red bends least. Angle of deviation is least compared to violet because of its largest wavelength. Okay. Then why this light is splitting into 7 colors? Actually, the refractive index changes with the frequency of light and hence wavelength. As refractive index changes with frequency of light and wavelength, when light passes from air to glass or glass to air, first refraction takes place. Okay, first here, either here air to glass or glass to air, first refraction takes place, right? So from here first refraction takes place, and this is denser medium, no? Automatically this slows down the speed of the light rays, right? It slows down the speed of light rays. And here if we take from glass to air, it is entering into the rarer medium, means speed increases, means totally we will find the changes in the speeds. Okay, so generally if we see the prism, how we will see? We will see as if the both surfaces of the prism is parallel, but in actual it never happens that. The both surfaces of prism will not be parallel. So only each light incident at its own position and comes out. Okay, here actually we think that both surfaces are parallel to each other, so dispersion must not happen, but actually it never happens. Both surfaces are not parallel to each other. So as they are not parallel to each other, what happens? Finally the path will be different for different rays. One will reach first depending upon the wavelength, other which will follow the other. In such a way, depending upon the wavelength, they follow their own path. So only when light is incident on the prism, it splits into different colors only due to the reason that refractive index changes with wavelength as well as the frequency of light. Right? Now next, some of the examples for this is twinkling of stars, formation of rainbow. Now next, the fourth property of light is scattering. The fourth property of light is scattering. So scattering means, here what happens means, now for example this is a dust particle or any molecule you think. When a photon is incident, photon means light, incident on it, this molecule absorbs a fraction of energy from the photon. It absorbs a fraction of energy from the photon and again it emits that energy. This phenomena we call it as scattering. When a light beam goes through a medium, it hits the particles existing in them. Due to this, some light rays get absorbed and same get scattered in various directions. This we call it as scattering. So the intensity of scattering line depends upon the size of particles and wavelength. Now intensity is inversely proportional to 1 by lambda to the power of 4, wavelength to the power of 4. Shorter the wavelength, higher the frequency, scattering more due to waviness of lines. and its interaction with a particle. Where we see the waviness of lines, their scattering will be more. The wavier the line, there are more chances for intersecting with the particles. In such a way, wherever we find the wavier lines, there are more chances for a photon to intersect with the particles, and there are more chances for the scattering of light, right? And examples are red color of sun at sunrise or sunset, white color of sky at noon, blue color of sky due to this scattering phenomena. Now let us discuss the examples based on this reflection, refraction, total internal reflection and scattering. One after other, let us discuss about some examples. First, mirages. Now here, how these mirages are formed means, these are the layers nearer to the earth and above that far from the earth. Now in summer season, if we stand on the earth, we find very hot, and if we in the same summer season, if we go on the top of the hill which is far from the earth, we find cool air is coming, right? Means here nearer the earth we are feeling hot air, means here it is acting as rarer medium nearer the earth. Now as we are going in upward direction, means on the top of the hill, I said that we are feeling cool air, we will get cool air, means their cool air means at top it will be denser medium. Nearer to the earth, all layers are of rarer medium. As we go in top direction, the layers will become, we will find a denser medium. So first, if we take a tree, here the light rays from the sun first incident on the tree, right? Now it reflects, this tree reflects that sun rays, and that sun rays are traveling towards the rarer medium, means towards the earth, okay? But here above that ray, as we go up, I said it is denser medium, no? So now here at one particular ray whose angle of incidence is greater than critical angle, then without entering into the rarer medium, from here only it starts reflecting. The same total internal reflection process. First it is traveling towards the rarer medium, then as angle of incidence of these reflected rays changes, at one particular angle of incidence we will get critical angle where refracted ray becomes 90 degrees, and when angle of incidence is greater than critical angle, then it reflects back in the denser medium. Now here the light is reflecting back, so now the person will see the illusion of this tree. Okay, now see here again I am drawing, this is the dense layers, this is the rarer medium layers. Now this is the tree, right? Light first incident on it, as usual first it travels towards the rarer medium. At one particular angle of incidence, it grazes the surface, means R becomes 90 degrees. When this angle of incidence becomes greater than critical angle, then it reflects back into the denser medium itself only, and the observer sees the image. These rays are coming from this particular point. This is the virtual image or an optical illusion which a person sees due to total internal reflection. Now next, rainbow. So rainbow, if you want to see rainbow, one part of must rain, in other part sunlight must be there. So here dispersion, reflection, refraction, total internal reflection, all properties will follow up in this rainbow. So rainbow is divided into two types, primary and secondary rainbow. First, primary rainbow. First, these two are the raindrops. Now this is the incident sunlight. Okay, incident, I am writing incident sunlight. Now when it enters into the raindrop, now this is the denser medium and this is the rarer medium. When it enters into the rainbow, it refracts. Here it refracts. Now due to dispersion, splits into 7 different colors and incident on second surface of the raindrop. Now here angle of incidence will be greater than critical angle. So it again reflects back. It undergoes total internal reflection here. Y means I is greater than IC. It undergoes total internal reflection and again refracts. When it comes out, again refracts. Okay, again it refracts. In primary rainbow, we will see red at the top, violet at bottom. In VIBGR, we will see red at top, and that is in rainbow, red will be at top, violet will be at bottom. So here how many phenomena are taking place? Refraction at first layer, reflection here, second layer, again refraction while coming out, right, and it will be intensified. Now next, secondary wavefront, incident ray, 2 raindrops. Now here refraction takes place at first surface. Okay, now here I becomes greater than IC. For both raindrops, I becomes greater than IC and it reflects. It undergoes total internal reflection. And again here, again it undergoes total internal reflection. Here also I will be greater than IC. Again it undergoes total internal reflection. And again at the first surface while coming out, the refraction takes place and they come out. And when we see this rainbow, violet color will appear on top, red will be at bottom. And this will be not so intensified as that of the primary rainbow. Now next, why sunset is red? Why means during sunrise or sunset, these rays has to travel the longer directions. Okay, so now we know that red has large wavelength, so scatters least. While sunrise, earth rotates towards the earth. At sunset, earth rotates away from the earth. Okay, so sunrise, earth rotates towards the sun and at sunset away from the sun. So as red is scattered least, around that sun we find only red color. As it is scattered least, we find the total red color nearby the sun. Now next, why sky appears blue? The same phenomena. Here the blue color light is having shorter wavelength, so it scatters more compared to other light. Here what happens, the sunlight when reaches the earth in all direction, due to the gases and dust particles present in the atmosphere, this light is absorbed with that particles, and again these particles scatters the same light. As blue color is having shorter wavelength, these particles scatter blue color more compared to other colors. So as blue color is scattered more, we find sky as blue. At noon time what happens? We find sky with white color. Why means at noon time what happened? Correct, sun will be overhead of earth. Sun will be overhead of earth. So here the scattering of light is least and we will find white color. Okay. Now next, p-hole refraction. P-hole refraction. So door viewer or spy hole we will say. In this, the outside person cannot see inside, but insider can see who stood outside of his door. In this p-hole refraction, we will use two concave lens and two convex lens. So here this one and 2, these are concave lens, and these 3 and 4 are convex lens. So observer can see the image of the person who stood by the phenomena of this refraction of light. Now next, the swimming pool appears shallower due to refraction, due to light travels from rarer to the denser medium. Now the fifth light property is intensity. So first, before going for the intensity, let us define superposition principle. Let us take, these are the waves, two waves, one with displacement y1, other with y2, are traveling in a same medium along same direction. So the resultant of this wavelength is written as y1 plus y2. So the summation of the resultant displacement is equal to the algebraic sum of the displacement of individual waves. That we call it as superposition principle. Now, if this resultant displacement is different from individual displacements, we call it as interference. So what is interference? The change or modification in resultant displacement, we call it as interference. Such, or as maximum displacement means what we will call amplitude. So we can also say the modification in amplitude. Intensity is directly proportional to amplitude square, no? So we can also say the modification in intensity of light waves. Okay, we call it as interference. Now there are two types of interference. One is constructive interference, okay, and other is destructive interference. Constructive interference means if y equal to y1 plus y2, if the resultant displacement is summation of the individual displacements, we call it as constructive interference. There we will find maximum intensity points, and the path difference between any two waves for constructive interference will be integral multiple of a wavelength. And destructive interference means if resultant displacement is the difference of displacements of individual waves, we call it as destructive interference. There we will find dark regions or minimum intensity points. And here path difference for such between any two waves will be equal to 2n plus 1 lambda by 2. Right? Now next, the sixth property of light is diffraction. Right? Diffraction. So diffraction means bending of light. Do you know, if we sit in this room, we will hear the sounds coming from other room. Why? Because sound waves have the property of bending around the ventilators and entering into the room. That bending of sound waves we call diffraction. Even the light has the same property. If we take small particles like sand particles, when light is incident on it, it enters into its shadow region. So we will not find any shadows for tiny particles. The reason is the bending of light into the shadow region. So that bending of the light around the obstacles around the obstacles present, we call it as diffraction. Right? Now next, polarization. So polarization means, now whatever the lights we are seeing in our home, we call it as unpolarized lights. Unpolarized lights means here light spreads in all directions. Now if we keep a bulb or tube light at one corner of the room, we see the light spreads in total room, means it is having the property of spreading in all directions. But polarized light means it just travels in one direction only. It will not spread. It travels unidirectional, we can say, travels in one direction only. Such phenomena we call it as polarization. Now lastly, let us go for the theories of light. A general view I am saying, first Newton corpuscular theory. He said that corpuscle means particle. Light travels in form of particles in such a way. Okay? And the colors is only due to the various size of the particles, and according to his theory, velocity in denser medium is greater than that of the velocity in rarer medium. So on his theory, he successfully explained reflection and refraction properties, but he was unable to explain interference, diffraction and polarization. So now next, Huygens wave theory. So he said that light travel in form of waves. Do you know what is wave? Wave means a disturbance created in medium. So when you sit on the shore of the pond, what you will do? You will drop a stone in that water and you will find the circular waves moving in forward direction. Okay, that disturbance created in the still water due to throwing of stone, we call it as wave. So Huygens says that light travels in form of wave, and he successfully explained reflection and refraction properties on this wave theory. After Huygens, Young, a scientist, he successfully explained the interference and diffraction properties based on wave theory. Okay, now let us go for Huygens theory or Huygens principle. So according to him, the light consists of wavefronts. Wavefronts means, if let these be the particles vibrating in same phase, the locus of particles vibrating with same phase, we call it as wavefront. We call it as wavefront. So this may be plane wavefront, spherical wavefront, right, or cylindrical wavefront, right. According to Huygens, again these are the points vibrating in same phase, I said, no. According to him, again each point emits some waves. These waves he called it as secondary wavelets. So according to his theory, the each and every point on a wavefront acts as source for secondary wavelets. So this is Huygens principle. Now next step, Planck's theory. According to him, the light reaches the earth in form of photon, and the energy of that photon is equal to E equal to h nu, or integral multiple of h nu, where n equal to 1, 2, 3, so on. The integral multiple of 0, 1, 2, 3, so on. Now next, After, as years passed, scientists said that light is having dual nature, means Newton's theory, particle theory is correct. Okay, Huygens theory, wave theory is also correct. But here, when we do experiments on particle nature, wave nature will be hidden. When we do experiments on wave nature, particle nature will be hidden. But light has both particle as well as wave natures. That we call it as dual nature of light. So quantum theory proved this. Okay. Now next, electromagnetic theory. So it says that this is the combination of a spectrum which consists of visible region, infrared region, micro region, wave region, radio waves region. Next, below this, ultraviolet region, right? Now next, gamma, X-ray, gamma, so on. Only visible region we can see. These are of higher wavelength, these are of shorter wavelength. The combination we call it as electromagnetic spectrum. So light comes in form of electromagnetic spectrum. This is about electromagnetic theory. So this is about the 7 properties of the light. If you like this video, like it, share it, subscribe it. Thank you.